So there are already deployed IP studio facilities in broadcast trucks. These are typically used on higher profile events. They're pretty expensive trucks, but they are existing today. Problem is, with any type of outside production like this, it's expensive. Sending production crews to site, sending operational crews and engineering crews to site costs money. Typically, it can cost more money than the hardware itself that you're sending to site, just because of the, all the transport and accommodation costs. So one of the focuses here at Suitcase TV is looking at how we can do remote production in a different way by leveraging the new IP technique. So the biggest cost for many productions is people. So if we can move to a model where we've got remote production, where you keep some of the people, not necessarily all of the people, but some of the people back at the production center, where they go home at the end of the day and they aren't costing you money to be on site, we can do more productions for a lower budget. Now, this isn't just about making existing productions cheaper, it's opening up the market to more productions, more content. Live content is what's keeping viewers engaged with channels. So this is all about trying to get more content on air. Now, an obvious way of doing remote production that many people may have read about in press so far is simply bringing back all of the signals from the event site back to a fixed gallery in a production center. Now that works, that's remote production, but it's not really true remote production. It's just transplanting all of the sources, and it can get costly. Now if you're doing high-profile sports event, lots of big sports grounds now have put dedicated fiber links in. You can do this, and it's, for those kind of events, it kind of makes sense. But for the lower-end market, it's not practical to relocate all the signals. So if we look at the IP studio diagram we had before, look at where the people are. Obviously, we have engineering people and camera operators, vision, direction, audio, and other people managing graphics, VTs, EVS-type operators. In an ideal world, we're going to relocate and split those so we have the majority of those back at the production center and only have the bare minimum at the event location. Now, this is the first kind of way of doing it, is relocating all of the sources. But of course, it's this link is where a lot of the expense comes in then. And of course, if you increase the number of sources, the link budgets increase linearly, and it gets very expensive very quickly. It's not practical for all but the higher profile events. So if we think about what we're actually doing when you're vision mixing or audio mixing, we can separate off the control panel from the actual crate. That's typically how it's all done nowadays anyway. If we move the heavy lifting devices back to the event site, then of course, we only need to feed the high bandwidth to the vision mixer on site. So actually, the link bandwidth suddenly goes much lower. Essentially, we can maybe just relocate a multi-viewer feed and a final program output feed of the vision to that site. That sounds like a solution, but there's a major problem with it. And I've seen this in real trials, unfortunately. On site, if you imagine the cameras are capturing time at, in this case, 15, and that's what your local, the vision switcher is processing those frames. If you have an operator located back at your production center, even on a fairly good broadcast encoder contribution link, there's probably going to be at least 4 frames of latency on that link, which means the operator who's sat in front of this desk looking at the sources, choosing when to switch between sources, they're looking at pictures 4 frames in the past, at least 4 frames in the past. So when they're pressing buttons, making switching decisions, they're going by things that happened in the past, which means for live sports, fast-moving sports, when you press a button to go from source 1 to source 3, that's what the vision operator intended to see. Just as the foot connected with the ball, they should have connected, switched to a different camera angle. But actually what the viewer sees is a few extra frames of that previous source. It's not a solution. So simple remote control, unfortunately, is fundamentally flawed for fast-moving events. For some events, it's perfectly acceptable. A few frames delay on some of the switching, maybe that's OK. But again, what we're trying to target is this fast-moving sports at the moment. So you can't get rid of the latency. Anyone who says they can get rid of the latency is lying. There's always going to be latency. The only true real-time video is analog video. We moved past that years ago. SDI has latency. It's just a very, very small latency. So we have to embrace it. We have to deal with it. What I've been focusing a lot of our time on is how to manage that latency to allow you to do frame-accurate switching remotely. The way we've implemented that is take those sources, make proxy versions of them, so lower resolution, lower bit rate versions, timestamp them accurately against that PTP time clock, send those back to wherever you want your operators to be, back at the production center in this case, display them on a UI so that, just like before, they can see them at some sort of delay. I've rounded it to 5 frames here to cope with some variability perhaps. And of course, this link, if it was even further, it could be a bigger latency than that. Who knows? Now, of course, what we then do is we insert some buffering here on the event site where we store all of the high-res content in memory. We don't want to commit it to disk. That would lower its quality. We want to store it uncompressed in memory. And then we want to feed it into a vision mixing process and audio into an audio mixing process too at some time offset. So that the actual vision process operates, in this case, 10 frames behind the actual capture time. That means that when an operator presses the button to switch between source 1 and source 3 at the point they see the action on screen, there's time for that message to get back to here, for the vision engine to connect to the appropriate multicast stream that's running in a delayed mode, and for the final program output to be switched on the correct frame. And with this compensation of the time, we can achieve this. Now, of course, that final mix is all well and good, but it's happening 10 frames behind real time, which means with the additional maybe of 4 frames latency on that link, the final program contribution, okay, we're looking quite far behind now. So clearly we can't use this for the operator. If we did, the operator would be pressing buttons and get really frustrated that 9 frames later they were seeing the switch happen, and that's not acceptable. So we have a solution for that, which is to do another mix using the proxy sources. Now, this could be done with traditional hardware, but of course, having 2 mixer crates gets expensive. We're doing it in software at the moment, so of course it's a bit more practical to do a second mix. But essentially, by using those proxy sources, we can simulate a real-time switching, so the operator, when they're pressing buttons, sees the program output change immediately, but actually the real high-res switching is happening back on site a few frames later. But importantly, what goes to air is what the operator intended to see. And with this method, we can handle any link latency. Now, if you're using packet resending technologies to kind of protect against going over public internet links, that could be a really big latency. That might not be practical for vision operator to talk back to cameras, but maybe the use case justifies it, who knows. But where are we going? So that's good, but. And of course, we can do this with audio as well. That's the same thing. But what about if you've brought your operational staff back to the production center, you also want to have graphics operators back at the production center too. But they're in the production center, and you need to get those high-res signals to this mixer here. That's a bit of a problem. So it's not a big issue. What we do is we have another process doing the exact same thing, where we generate proxy versions of those sources so that we can feed that into the same user simulated mixer. And then we do a downstream high-res mix at the production center at a different time offset, so that as the operator is switching between different sources, whether they're on-site or local, we can do a frame-accurate switch between any of those sources. And that's exactly what we did with BBC Sport last summer. We worked with them on a trial at the Euro 2016. This was alongside their traditional facility with a lot of people on site and a lot of facilities on site. Now, they had a few different locations. London really was just routing because that's the BBC's network center. But essentially, in the studio in Paris, we had a collection of sources. In this case, it's a traditional installation, so it was all SDI. From our point of view, it could have been IP sources, and in future it would have been. But it is what it is. So we're generating proxies of all of those sources, passing them across the network so that you can have an operator connect into those proxy feeds and see all of the sources wherever they are, whether they're locally in Paris or back at the production center in Salford in the UK, and then they control that mixer. You spend your bandwidth on that single program feed coming out of Paris, and ultimately that could be it, remote control mixing. But as I've said before, in reality, you've got sources back at the production center. In the case of BBC, VT sources of archive content, graphics, they would want that to be local. So we had a downstream mixer running in Salford at a slightly different time offset, we have the sources coming back onto the network again, so people in Paris can see those Salford sources and allow you to switch between them. And then we very carefully manage the timing between the Paris mixer and the final TX mixer so that by the time this contribution link came across, we were able to do a frame-accurate switch between all of those sources. So yeah, quite a successful trial. I think the next slide's got some photos on it, just to, this is the clients operating in Paris, there it is in Salford. Same user interface, same sources. Operator doesn't need to care where the sources are. They just switch between them, and they get a final mix.